Hi once again, fellow teachers. So we are now on the second video of this series. Last time we talked about electronic grade sheets. This time I will show you how to use it to analyze objective test items. Yes, it is a rare occasion where teachers take time analyzing their multiple choice questions. Most teachers don't keep electronic question banks, or if they do, they only keep old test documents. They also recycle items to make new ones. If assessment experts are to evaluate this practice, we are doomed to fail their expectations. Our excuse will always be the lack of time to do it. It is impractical, it is the unusual, or it is not the usual strategy being encouraged by administrators. But always put in mind that good assessment should complement good learning. It is likely that we will generalize that our students are low performing because of one bad assessment instrument made by us. In the same manner, we may overreact to what we call as a false positive when students got high scores because we made them believe they are good with a lame assessment instrument. You may argue that there are plenty of assessment techniques, so I want to emphasize that our use of spreadsheets is limited only to objective multiple choice tests. Multiple items tests are easy to make, they can be stored, they can be improved and reused, easier to check. You can even ask somebody to do it for you by just providing the answer keys, and statistically, performance can be measurable with all the descriptive indicators in place. Expect also less variance compared to, let's say, an essay test. Item analysis can improve the reliability of objective tests, so our focus is now in place. And this allows us to give the best performance award to a really deserving student. I was able to get a good item analysis software from CTAS. It's a company who specializes in psychometric evaluation tools. They emailed me a simple item analysis spreadsheet for this purpose. Item analysis will only be relevant if you are keeping copies of your tests because it will guide you on how to improve on your test items. It is greatly encouraged that you learn also how to create electronic test banks so that the use of item analysis can be optimized. I'm not the perfect person around to explain classical test theory, but you have no choice for now. So I will give you some bits of it. Do you really spend time in constructing multiple choice questions? If no, chances are you will create a too easy item or a too difficult one. Item difficulty is one thing that we look into when we do item analysis. Most of the time, we only know that we gave a difficult test after we get the results. Is it possible that before you gave a test, you already are aware of how difficult or how easy it is? Of course, different sets of students can respond differently to the same test. This is why reliability must be ensured in the creation of your objective multiple items test. Each of the items must statistically produce consistent results or consistent scores across different types of test takers. It must be able to define a clear boundary between a high and a low performer. For example, there are items that were answered correctly, mostly by low test performers. So basically, we should expect that high scorers must also be able to answer them too. But what if the high performers were not able to answer these items correctly? That is the time when we suspect that there is something wrong with the item. Another example is when we have a very difficult question and we expect only the high performers to answer them correctly. But then we found out the opposite. Again, we need to check the item to see what's included there that confused our high performers into getting the correct answers. They refer to this as the discriminatory power of a test item. How an item performs at assessing learning is one way to support the validity of our teaching approaches. Of course, validity is a much broader theme, as I have mentioned a while ago. But somehow there is a connection between reliability of test items and how valid learning is measured among students. Also, knowledge has been organized into different levels, right? If you can still recall Bloom's taxonomy on the cognitive scale. So don't expect that the item analysis can measure the level of cognitive skills here from low level to high level. Instead, it works on how students of different cognitive capabilities are able to respond to items of different cognitive levels too. Because we're dealing with students of different levels of cognitive capabilities, we have to create an assessment instrument that is fair to all of them. It must not be too difficult or not too easy, and that all items of the test are reliable regardless of how many generations of students took it. So in our test banks, we should have a container for easy questions and difficult questions, as well as those in between these levels of difficulty. By being aware of item difficulty and its ability to separate fast learners from slow ones, we can create a reliable measuring instrument. If something is wrong with a particular item, you can edit them. Sometimes it all boils down to the choices that you offer to your students. Thus, there is what they call as a distractor analysis. It's an extension of item analysis where you can have a statistic for every choice you offer your students. How much the other choices can distract the student from selecting the correct answer is also worthy of intervention and can pave the way into improving previously bad questions. By examining our test items closely, we can get information on the possible misconceptions that happens inside our classroom. As teachers, we have to intervene by correcting this as soon as possible. So to wrap things up, item analysis can provide us with a good information on number one, we have item difficulty, which can be the number of people who answered correctly over the total number of test takers. So the more it approaches 1, the easier it becomes. We sometimes call this the difficulty index. Also, the farther it is away from 1, the item becomes very difficult. Secondly, we have the discrimination index. This is another statistic that tells us how intelligent students get correct answers, especially on difficult items, compared to your low performers, meaning the item was able to draw a clear line between the high and the low performers. This is computed using this formula. So here we have the top 27% who answered correctly. So these are your high performers who answered correctly divided by the total number of your high performers. So the top 27% who answered. Now this value minus the bottom 27% who answered correctly. So these are your low performers, meaning they got low scores. But on this particular item, they got it correct. Divided by the total number of your low performers or your bottom 27% performers. Now your top 27% and bottom 27% can be changed. Maybe you can adjust this depending on your own definition of high and low performers. Maybe you can use quartiles, the top 25 and the bottom 25. Or maybe you can consider the top 33% and the bottom 33%. But again, out of convention, we will use 25 to 27% as shown in most item analysis tutorials in YouTube. And finally, we have distractor analysis. This can allow us to fix or rewrite our items after analyzing how distractors in a multiple choice test are performing. Now, here's the spreadsheet. This also comes with a manual. You can read this on your own. So let's go directly to analyze the difficulty of our items. I already have here a data of a 30-item test taken by 50 students belonging from 2 sections in my aquatic zoology class. So let's place 50 students here first. I already encoded the answer key here, so let us now input all the answers of the students in this 30-item test. Now, let us proceed to the main output sheet. Here, difficulty or item difficulty is represented by this column on p-values. So if we set our difficulty level to values less than 0.4, then we have about more than 20 difficult items here out of 30. We can consider this as a difficult test. So where are the easy items here? I think we only have item 14 here. That is the easiest because it got a p-value of 1.0, meaning everyone got it correct. The rest are of medium difficulty. Of course, you can adjust your standard of difficulty by setting your own difficulty index. So let's say those getting a p-value of 0.3 and below. Okay, so here you can check some of the descriptive statistics. The one who got the highest score here scored 25, while the lowest one only got 4. Now, let us look at how the items discriminate between high and low performers. Now we have an initial result telling us that this test is quite difficult. So let us now look if indeed the items reliably measured performance. The manual instructs us to look for the small r, the RPBIS or RPBs, or point by serial correlation values. This provides an index on whether students who get the item correctly are scoring highly, which is of course, the hallmark of a good item. So let's check it. I tell you, this is the first time I am doing this to my very own test, and I'm quite anxious of the results. And oops, we have a blank cell here on our easiest item. This means this item cannot differentiate between high and low performers since everybody was able to correctly answer the item. Our primary goal here is to get positive values. So the higher the values, and as long as it remains positive, we have more high performers answering correctly than the low performers. And RPBs of 0 indicates that there is no relationship between the item and the total scores. This means that the item is providing no information and the item responses are essentially random with respect to the total scores. But as RPBs increases, it indicates a stronger relationship between the item and the total score. So a value of 0.2 means it's already a decent item, and highly discriminating items will have values in the 0.5 or 0.6 range. We have highlighted cells here. The yellow ones are positive but very low. These items need review because it seemed that it doesn't really discriminate between high and low performers. The negative value in this pink cell tells us that more low-performing students answered this correctly than high-performing students. This is kind of anomalous at this point. We thus have 7 items that require in-depth analysis by looking at the question itself or on the choices that I included. Of course, the easiest question can now be removed from our test bank, or you may just want it to remain there as a bonus item. So let's look at item 9, 13, 26, 27, 28, 29, and 30. Now let's go to the option output and check our distractors. The P for the key is greater than the P for any of the distractors. That is, you don't want more students choosing one of the distractors than the key. Also, RPBIS for the distractors must be negative, and the RPBs for the key should be positive. So if an RPBs for a distractor is positive, this means that smart examinees are choosing it, and usually want the not so smart examinees selecting the incorrect answers. We have 3 options here. Option N tells us of the number of examinees who answered the letter. So for item 1, 3 out of 50 answered A, 16 answered B, 25 got the correct answer C, and 6 people answered D. The second option here refers to p-values, or difficulty, or the probability that a particular choice is chosen as the answer. Take note that all these computations are relative to each other. This sheet will actually help you understand your test items and suggest possible lines where you can improve them. So for item 1, B seemed to be a good distractor here, so you may want to change this if you want to improve your student's chance of getting the correct choice, which is C. Let's go down to the RPBs option. You can see that most of the other distractors have a negative value. So basically, we can conclude that they are decent distractors. Now let us go to those items that we believe needs improvement. Okay, so let's have item number 9. We have 2 positive values, choice C, which is the correct answer, and choice D. It means that the high-performing students seem to make a mistake by answering D instead of C. So let's look at the exact question. I have here the question. Item 9, water through the action of the choanocytes flagella enters the sponge via the blank, spanning the external and internal walls of the organism. So this is a question on the structure of sponges. Okay, and of course, the correct answer here is C, the porocytes. Most probably, some of my students here have some misconceptions about how water moves into and out of the sponge. The high performers also consider the osculum because it seems obvious that water also moves in from this large opening. Now, I'm beginning to like this procedure. Let's try to look at another item here. We have item 13. We also have two positive values for item A and B, telling us that our high performers have a hard time choosing which of them is the correct answer. 21 actually got it incorrect by answering A when the correct answer is B, answered by 16 students. It was also mostly from the high performers who got it incorrect. So let's look at the question again. Now we have here the cnidarians. What cells are used by cnidarians to capture prey? Okay, so you have nematocysts, nidocytes, amoebocytes, and leukocytes. Now, as I see it, I think those who answered A are so eager to answer the item that they miss that I'm asking for the cell and not the structure inside it, not the harpoon-like weapon in the cells. And I think there's no problem with this question. Now, it's not really a requirement that you really follow the numbers. So as a teacher, you must also use your subjective judgments when considering your test items. Okay, I'll go to that item where mostly the low performers answered better than the high performers. That was item 26. And here it is. So I think this is also quite decent since 21 students answered A correctly here. But it is more of the low performers. Also, most of the high performers seem to choose C. And of course, got the wrong answer. So here we have jellyfish differ from sea anemones in that okay, only one has a mouth facing upward. B, only one has tentacles. C, only one uses the same opening for food and waste. And D, only one has stinging cells. I actually adapted this question from an online test. I admit this is not really how I frame my questions. I also do not find problems with the choices, only that they appear confusing, especially for choice A, where a jellyfish may also turn itself upside down in a water column, so perhaps some critical students eliminated this immediately. So basically, I will remove this from my bank, or maybe I can just reframe the question. I will no longer look at the other items again, but as you can see here, those highlighted in yellow seem to need our attention. What is important here is that using this item analysis spreadsheet allowed us to perform a challenging post-assessment procedure in a few hours only. Without it, who would care to do it manually anyway? So it's thus recommended that we keep electronic test banks so we can really optimize our item analysis runs. That will be the third video in this series. So bye for now. I will see you again. This is Professor Bryan Yves Araneta of Iloilo State University of Science and Technology.